Hi, welcome you all. This is Dr. P. Raviraj, Professor and Head of the Department of Computer Science Engineering, Kalangir Karunanidhi Institute of Technology, Coimbatore. It's my pleasure to deliver about the lecture regarding the syntax analyzer in compiler design. I'm very happy to brief about the role of syntax analyzer inside the compiler design. Actually, syntax analyzer is the second phase of the compiler, which is used to analyze the syntax of our source program. Actually, syntax analyzer, it creates the syntactic structure of the given source program. In what way it will create the syntactic structure means with the help of that algorithm parser tree. Parser is one of the important algorithm that is used inside this syntax analyzer for the purpose of constructing the parser tree. So the syntax analyzer is otherwise called as parser. Actually, parser, how it is working means it will be getting the input based on the syntax of context-free grammar. Already we have studied about the context-free grammar details in theory of computation or any kind of automata related subjects. Actually, context-free grammar is a kind of grammar which is used for computational purpose that is represented in the help of Backus-Naur form, BNF we used to call it as. So the syntax analyzer plays a major role inside the compiler for identifying the syntax error. So context-free grammar is one of the tool which is help for the syntax analyzer for identifying the syntax specification of the programming languages for designing the grammar also. So I am very happy to brief about the parser. Parser is a kind of algorithm which is used for generating the syntax analyzer inside the compiler. So parser, the role of parser is to construct the parse tree with the help of a stream of tokens. Here if you would see this diagram, we have given normally the source program, whether it's maybe a C or C++ or Java codings. The first phase of the compiler lexical analyzer will read the source program character by character. Then it frames the token. That token will go as an input for the syntax analyzer that is called as parser. So here the role of syntax analyzer is to analyze the syntactic structure of the source program which is given as a token. Then that will be constructed as a parse tree. Then that will be given to the input for the next phase of the compiler, that is syntax semantic analyzer. So in parser there are two kinds of parsing methodologies. We used to call it as top-down parser, another one is called as bottom-up parser. So what is top-down parser means the parser tree will be constructed and the process will be working based on the root two leaves. That is, the parse tree is created top to bottom starting from the root. Then another kind of parsing method is bottom-up parser. It's just reversible for the top-down parser. That is, the parser is created from leaves, that is bottom to top. It is starting from the leaves. So these two methodologies are very popular inside the compiler design. So some compiler may prefer top-down parsing methodologies. Some advanced compiler may prefer bottom-up parsing algorithms. In top-down parsing algorithm, the input scans from left to right. In bottom-up parsing, the input scans from right to left. In top-down parsing algorithm, a lot of parsing algorithm, we will name it as a predictive parsing algorithm, recursive and non-recursive predictive parsing algorithms. There's so many algorithms. We used to call it as LL for top-down parsing. That is left to right scan of the input and leftmost derivation. So that it is called as LL. For bottom-up parsing, it is based on LR parser. That is, L stands for left to right scan of the input and R stands for the rightmost derivation. So what is context-free grammar? Because we have already studied this one. in theory of computation or any kind of automated subject. But anyway, it's my pleasure to brief a few things about the context-free grammar. So context-free grammar contains a finite set of terminals, finite set of non-terminals, and finite set of production rules, and one starting symbol. These are the four necessity input which we require inside the context-free grammar for constructing the parse tree. This is one best example. If you would have seen that, this is the concept of context-free grammar. This totally we call it as production rules. In this production rule, the left side we will have only one non-terminal. On right side we have a combination of non-terminal plus terminals. So many productions has been defined under one non-terminal. So this is the normal procedure we have to follow in defining the context-free grammar. I'm very happy to brief about the derivation methods because top-down parsing method is based on the leftmost derivation. Bottom-up parsing method is based on the rightmost derivation. So here leftmost derivation, if you would have see this derivations, this derivation is based on the previous input. So here this LM stands for leftmost derivation. First it starts from root, but this derivation is based on the leftmost derivation because here there are two non-terminals, but in the next production we have applied only the leftmost non-terminal here, then the rightmost non-terminal. So the derivation is applied based on the leftmost derivation, so it is called as top-down parsing, leftmost derivation. Here if you look at the difference, here we have applied the leftmost non-terminal has been changed into corresponding tokens, but here there are two non-terminals, but we have applied for rightmost non-terminal here. That is the only difference between leftmost derivation and rightmost derivations. So this is a few examples for constructing the parse tree. In parse tree, it is otherwise called a syntax tree. So parsing is the main algorithm which is used inside the syntax analyzer. Here we have a root node and leaf nodes. For this derivations, E derives minus E. This is the parse tree we have. This is the parse tree for this derivations. This is the parse tree for this derivations. Likewise, we will construct a parse tree. The compiler will automatically construct a parse tree for the given equations. In grammar, there are two important types. One is ambiguity grammar, another one is called as non-ambiguous grammar. So actually ambiguous grammar means what means is one of the important terms which we consider inside the lexical syntax analyzer. That is, a grammar produce more than one parse tree means it is called as ambiguous grammar. If you look at this example, the same grammar is producing the same string but different kinds of derivation procedure. Here we have applied this production rules, but here we have applied the different production rule, but anyway we are getting the same output. So the syntax tree structure is also a different one. So this grammar, then we used to say it is an ambiguous grammar. This kind of grammar, the syntax analyzer try to avoid for constructing the syntax analyzer because it leads to the contradictions or conflicts when we compile the program. So these are the important points we have considered under the syntax analyzer. Let me conclude the role of syntax analyzer. Syntax analyzer is one of the important phase of the compiler because normally the programmer may do a lot of syntax error mistake. So this syntax analyzer will find out those errors with the help of parsing algorithm. So in this presentation we have covered about the role of syntax analyzer, then the algorithm which is used inside the syntax analyzer, that is parser, then type of parsing method, that is top down and bottom up parsing, then what are the kind of derivation which is applied in the top down and parsing method with the example. So I wish you all the best. Thank you to one. Thank you very much.